back.
That's negative, right? Like if it was going the other way, it
So
would be positive.
forget this,
But if
right?
r equals 0,
So this is basically the top one. The lower one is coming back through K. So which is same thing.
it just stays negative. It comes here.
You don't have to worry about
Becomes this multiplies K by negative.
Well, it will
It
be
comes-
minus
it
anyway
comes in
because
negative
this
now.
is
So that's
giving
basically
us
what
the
we're doing.
minus.
Yeah, your
feedback.
reasoning has reason, where like my reasoning just has rows.
Yeah, yeah. I mean, I'm just looking at it like it's a calm kind of diagram.
Yeah.
It makes more sense.
So
Yeah.
basically,
So when you do the ratio of the transfer functions, like you just get a K because you're dividing this by this. So it's like
not there yet, but it looks likely. Yeah, it definitely looks like it.
yeah, you just get a K.
So what value of K will reduce the ratio? Low K.
I just give it up. So the solid for CS is negative.
right? You understand now? Very good.
Wait,
So what is the ratio now?
K.
What is the ratio? 1 over K. C over.
Also the opposite. So it's
That here. Yes.
PCR.
So basically what you have is, and this is 0. This is
So just that K equals infinity. or-
R is not there.
It's not there yet, sorry.
So this circuit will be done like this. E.
So if it's in a parallel with K, that makes it 1 plus 0.1 K over.
The loop goes from K. And then loop goes back. And this is like.
Yeah, I get the way.
So then you have the ratio. Now we are looking at the ratio C over D, C over R. Now C over D over C over R. From those two equations, equation 1, 2, from those two equations, you will get 1 over K. You get 1 over K. Now the question is, if you want to minimize this disturbance impact, your K should be a large value. Right? So that's
How do we know what ratio to take, whether to do C transfer function C over R or on the
so
top
this
or
is
the
the
bottom?
top is the here the disturbance one, the divided overall, because we are looking at the disturbance,
Okay.
right? We are looking at the disturbance. So we start from it.
Okay.
Now you go for functions which are CT for R and CT for CD. Yes. So please do that. They are very easy because you do the partial fraction, it will be very simple.
Wait, how did we do C?
Yeah, so if everybody has written this,
Yeah.
final May 23rd, Monday, 7:15 to 9:30. Skylar told me this, so all blame goes to this guy. So you have to be very early. Please make sure that if you are coming from outside, you should start early.
So what should we let K be? Like any number?
Huh?
Over 10? K?
Okay, K value. So the value of K is given 80. When you solve these values, For this action, use K80. Use K80, please.
How did we reach that value?
Oh, this is given. This is given in the question. I have no way to reach that value. It's just given that K is 80 for.
It's given because it has to be decreased, right? So it has to be
Yeah,
right.
so a higher value. You can put 100 as well, but the sample question is saying 80, so use 80.
Yeah. Wait. Oh, I'm tripping. K has a value. Wow.
Yeah, it's 80.
Gotcha.
What are we trying to do here?
Reduce this ratio.
So,
So the next step
you want
is,
to get K to 1? Make it.
Well, if you're decreasing the value, like trying to get
A max, like go to infinity or negative.
I think when you use K value, the K represents like the gain of the system. So now you have like what the system is actually doing. So once we know like the properties of the system in the discrete domain, we can now go into the time domain and see how the system reacts with time. So when you reduce the ratio, you like obtain a ratio that now describes the system, and so we can then go
so
into
now you go for
the time domain with the reduced ratio.
CRS.
You just plug it into it.
Will be that value which you already calculated, 0.1K, which is 80, over S plus 6 plus 8, and multiplied by unit step function, so it will be 1 over S.
You could put the square.
Now
For what?
you can simplify it. So this is S squared
S plus 4
plus 6S plus 8, alright? S squared plus 6S plus 8. So this will be S plus 2 into S plus 4. So this will be equal to 8 divided by S into S plus 2 into S plus 4. So make the partial fraction and then find CT, please.